Welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on Structured Query Language. Structured Query Language, or SQL for short, is the language with which we create, update, and interrogate databases. SQL is a declarative language. This means it focuses on defining the output that it would like to receive, rather than as an imperative program would, describing the process to get there. At GCSE, we looked at the select, insert, update, and delete queries. If you need a refresher on these, use the links that I'll put in the video information to go back and watch the two videos from the GCSE course. You can still be asked in the exam to both write or interpret these types of queries. At A-Level, it's important that you understand the full variety of tools that you can use to create more complex where conditions for your select queries. There's the usual comparison operators with your equals, greater than, less than, etc. Notice that not equal to is a less than followed by a greater than. In allows you to check if a value is in a range you define in a tuple. So genre in comedy or action would mean if we were searching up in a films database and the genre of a film was either comedy or action, it would be selected. Like is a wild card. It means, for instance, film title like R would find film titles starting with the letter R. Sometimes we use a % symbol instead of like, depends which database system you're actually using. Between and lets you specify a range. Dates will either be enclosed by hashtags or by speech marks. Again, it depends on the database system you're using. So, date of birth between 1st of the 1st 2000 and 31st of the 12th 2009 would select all records where that is the case. Is null can be used to find records that have a field with no value. So for instance, if we wanted to find out which people we don't have an email address for, we could search for email is null in our customers table. And of course, logical operators and or not that can be used to combine different conditions. As well as being used to query a database, SQL could be used to create tables. Attributes in table definitions need to be defined in terms of their data types. In this table, you can see the available data types. Char n is for a fixed length string of n characters. When you call it, for instance, to implement course ID as we see here, we say char 4, meaning it will be a fixed length string always of 4 characters. Varchar is a variable length string of n characters. N is the maximum number of characters that it can hold, but we don't know how many it will take each time. That's because in this instance, we don't know how many letters will be in each person's forename. Int is short for integer, whole numbers as we would expect. Float takes decimal numbers. Boolean, true or false. Currency formats numbers to match regional currencies. Date stores day, month, and year, and time stores hour, minute, and second. As well as the data type, you also need to specify which field is the primary key and any fields that are not allowed to be left null. So if we have a table that is going to store a student ID, forename, surname, date of birth, and whether the student takes the bus or not, it would look like this definition below. Create table, then the table name, in this case students, followed by student ID, which we're saying is going to be an integer, can't be left null, and is going to be the primary key. Forename is going to be a variable length string of characters with a maximum of 20. It can't be left null because we need to know the person's forename and their surname and their date of birth. We've actually left takes bus as not carrying the not null because maybe we find that out later off the students. Then we've got surname, which is another variable length character of 25. date of birth, which is a date, and takes bus, which is Boolean. It can either be true or false. The alter table command lets you add attributes to a table, alter attributes in a table, or remove attributes from a table. To add an attribute, we say alter table followed by the table name. In this example, student. Then we say add followed by the new field definition. In this example, email, which is going to be a variable length string of characters that is up to 50 characters long. To change an attribute, we'll once again say alter table and the table name that we want to change an attribute in. This time it's modify column, and then we give the new definition. This definition replaces the old definition. To remove an attribute, we once again start with alter table and give the table name in which we want to remove an attribute, and then we say drop column and the name of that particular attribute. In a normalized database, we will have a number of fields that link tables. These links must be defined in constructing the tables. Let's consider a loans table in a library that stores the book ISBN, member number, and date borrowed. The book ISBN and member number come from their respective tables and form a composite key. The definition for this would look something like the table definition below. Create table, the name of the table we're creating. We'd declare the book ISBN and the member ID. You notice that in both cases, we're not saying that they're the primary key here. That comes later. Then we're going to declare borrowed because that applies to both the ISBN and the member ID. The date borrowed will differ, each different book that each different member borrows. Now we define those relationships. So we say that foreign key book ISBN references table books, book ISBN, and that foreign key member ID references members, member ID. This forms the relationship. We then specify that this is a composite primary key. That brings us to the end of this video on SQL. Join me again soon when I'll be back with a video on client-server databases. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.